All right, here we go. So we are going to go over 8.3 notes. We kind of covered it a little bit on Friday. That was a hot mess in of itself, so I apologize for that. Use that as an example of you need quality sleep. Make sure you're getting good quality sleep so you can be productive, because I did not get good quality sleep the night before and I was not very productive. And so anyway, I'm going to cover these notes as best as I can to explain it to y'all. Just as a reminder before we get going, if you're watching this right now, one of two things: you either weren't in class on Friday, or you're not going to be in class on Monday. Really, either way, everyone's going to be watching this even on Monday. Whether it be that you're watching it from the beginning or maybe you're watching it from where we left off at, because I did forget that I will not be in class on Monday since I will be at junior high track. So just know that. And then you have your test on Tuesday and Wednesday for those of you that will be there on campus. You will be having that on Tuesday and Wednesday, okay? So don't forget that. So make sure you're watching this. If you know someone isn't, make sure you tell them, hey, you got to watch this so that way you're ready for your test on Tuesday and Wednesday, okay? All right, so we're going to be writing equations of rational functions today. We've been doing it where we're graphing it based off of the equation. Well, this time we're actually going to be the ones writing the equation based off of the table and then, of course, the graph as well. So right now we need to find the equation of f of x. Now, I will tell you the easiest way to do it is to just do it first in factored form. So what we're going to look at is this table over here. I don't know if you can... I'm going to circle the table we're looking at. So this first table that we're looking at, okay, we're going to look to see, well, where are our x-intercepts? And so as a reminder, your x-intercepts are anywhere where y is 0, okay? So your value, let me get this a little thinner, your value where y is 0. So these three functions, or these three values right here, those would be our x-intercepts. So when we write our equation here, our factor in factored form, because this is a -5, I would write x plus 5, okay? And then down here on my next one, which would be x, it says it's -3, so that factor would be written as x plus 3. And then my last one here would be my +2, so the way I would write that as a factor would be x minus 2, okay? So then we need to move on to find our g of x equation, okay? And so, again, the same way, in order to do that, we're going to see, well, where do we have our x-intercepts in this graph? So we know that we have our x-intercepts at -3 and at -2. And so the way we're going to write that, sorry, I'm trying to color code so you can keep it kind of all straight. The way we would write our factors, where it says -3, I would write that as x plus 3. And where it says our x value, or our x-intercept, is -2, I would write that as x plus 2. Okay, so that's going to be how I find my factors of those two equations there that will then give us our equation of the overall function itself. Okay, now we need to find, or we need to complete the table of f of x divided by g of x. And as a reminder, you can use your graphing calculator if you would like to. Type it into your y1 and then go to your table. Or you can do your f of x value here of 0, this one, divided by 6, okay? And so for time's sake, I'm going to just go ahead and fill out the table. If you have any questions on how I got these values, please let me know, and I will explain them. I will show you, more explicitly how I got these, okay? So let me just fill this table out for you so that way you can see what we're talking about as we're going over this. That is 30/7, by the way, not 31/7. So So 30, let me do it this way, over 7. Which is approximately 4.3, okay? All right, so now we have our table value of our rational function here, our f of x over g of x, okay? And so what we need to know is we need to find out, well, what is our domain? So in order to find our domain here, we're going to pay attention to where our graph is undefined. Okay, so notice that right here we have 2 undefineds there. So when we go to write our domain, we're going to have -∞ to our -3 with a union from -3 to -2, union -2 to infinity, okay? Because we cannot include anything at -3 and -2 since that is undefined. Okay, I'm going to come back to the range after we've gone over our horizontal and our slant asymptote. So we're going to skip range for just a second. So now it's asking our x-intercepts. And when it's asking our x-intercepts, it is talking about just our f of x over g of x. Okay, so it's just talking about this part right here. All right, so our x-intercepts, that's going to be anywhere, anywhere where our graph, or our y value, excuse me. Oh, I'm clicking the wrong thing. I'm trying to get color coded here. Where our y value is 0. So we have one here. We have one here. Okay. So our x-intercepts are going to be -5, and you write them as an ordered pair. -5, 0, and 2, 0. Okay. You're going to have two different x-intercepts here. Okay. So then we move on to the next thing, and the next thing is a hole. And so some of you have asked me some questions on how we just, find out where the hole is. So just as honestly, an easy reminder, anywhere that you have a shared factor in your numerator and your denominator, that is going to be the x value of your hole. Okay. So because we know that our x plus 3 on the top and the bottom is our shared function, our shared factor, excuse me, that means that my hole is going to be where x is -3. Okay, remember you always do whatever is the opposite on the inside. So if it says +3, we would do -3. Okay, now we need to find what our y value is. So to find the hole, and we're going to do this down here at the bottom to give us room. So we're going to find the y value of the hole. Okay, refer back up here and notice I have the shared factors highlighted in yellow. So we're going to use the factors on the numerator and the denominator that are not shared. So the factors that I have not highlighted in yellow, that's what I'm going to be using, okay? All right, so it's going to be, I'm going to plug in my x value, where we've already talked that x value is -3. So I would plug in, anywhere I see an x, I'm going to plug in a -3. So I have -3 plus 5. Times -3 minus 2, and it's going to be over -3 plus 2. Okay, and so all I've done, I'm going to highlight this so you know what I'm talking about, but I'm going to highlight it in a different color. All I've done is I've plugged in this -3 for x in the part that is not the shared factors. Okay, so after you do this algebra here and you simplify this, you get -10 over -1, excuse me. And that is going to give you a +10. So my y value for my hole would be +10. Okay, and it's based off of this information down here at the bottom. Okay, that's how I knew what my y value would be. Okay, moving on down up here on our table of values that they're asking us to fill out, we go on to our y-intercept. And our y-intercept is anywhere that x is 0. So our y-intercept on this would be 0, -5. And so then we come to the vertical asymptote. Well, how am I supposed to know what the vertical asymptote is? So refer back up here to your factors, excuse me, and notice that this factor in the denominator was not a shared factor, okay? So whatever factor in the denominator was not a shared factor, that is going to be your, asymptote. Okay, so the x plus 3, that was on the top and the bottom, but I only have x minus 2 left in the bottom, so that means that my vertical asymptote has to be x minus 2. Okay, now one thing we talked in class about on Friday, was that if the degree of the top, the degree of the numerator, if it is greater than the degree of the denominator, we are going to have a slant asymptote. Okay, and one way you can look at it, because it's in factored form right now, our equation, how many factors do we have on the top? Well, we have 3. And then how many factors do I have on the bottom? I have 2. So because I have 3 factors in the top and only 2 in the bottom, that's how I know it has to be a slant asymptote, okay? And so we need to find what the equation is of this slant asymptote. So the way we're going to do it, first off, what we need to do actually is we're going to multiply our denominator, or numerator, and then our denominator out. So we're going to do that. I'm going to do the box method over here down in this bottom corner. And so the first thing I'm going to do just x plus 5 times x plus 3. So x plus 5 and then x plus 3. Okay, and I'm going to do the box method. So x squared, 5x, oh, sorry, not 8x, 3x. 3x, and then 15. Okay, so now this turns into x squared plus 8x plus 15, but I still need to multiply this by the other factor that's in the numerator, which is x minus 2. Okay, so I'm going to go ahead and multiply this by x minus 2. So I come up with x cubed, 8x squared, 15x, negative 2x, negative 16, oh, I'm sorry, negative 2x squared, negative 16x, and then negative 30. Okay. All right, so now I'm just going to combine my like terms. So my numerator is going to be x cubed plus 6x minus x minus 30. Okay, that's the going to be the standard form of my numerator. All right, now if you remember, we still have this x plus 3 times x plus 2 on the bottom as my denominator. So I'm going to multiply that out. But before I do, I'm going to go ahead and color code again to keep it straight for y'all. What I am boxing here in my red, that's my numerator. Okay, so let me change my color back to black. So now I'm going to multiply x plus 3 and x plus 2. So I get x squared, 3x, 2x, and 6. Okay, so when I combine like terms, I get x squared plus 5x plus 6. Okay, and so what I now have boxed in purple is our denominator. Okay, so going over here where it's telling us to write to write the rational function over here, I'm going to go ahead and write these equations, or these expressions. So x cubed plus 6x squared minus x minus 30, and it's all over x squared plus 5x plus 6. Okay, so now going back to my slant asymptote and how to find that equation, I'm going to use my function that I just wrote, the x cubed plus 6x, yada yada, over x squared plus 5x, and so forth. I'm going to go ahead and divide that. And I'm going to divide it with long division because even though that kind of was more difficult for us whenever we did this last time, whenever we were going over like polynomial long division, it's actually not going to be that bad. Hold on, though. I didn't mean to do the fraction line here. Sorry. Okay, so I'm going to divide x cubed plus 6x squared minus x minus 30. And I'm going to divide that by x squared plus 5x plus 6. Okay. So what I need to ask myself is, what can I multiply x squared by to give me x cubed? And the answer would be x. So when I take x squared times x, I get x cubed. X times 5x gives me 5x squared. And x times 6 gives me 6x. Okay? And so now I'm going to subtract these. And I'm going to go ahead and use a different color because I like using different colors. So x cubed minus x cubed cancels. 6x squared minus 5x just gives me x squared. Negative x minus 6x gives me negative 7x. And then I'm going to bring down my negative 30. Okay? And so then from here, I need to see, well, what do I need to multiply x squared by to give me x squared? And so the answer here would be 1. So when I take 1 times x squared, I get x squared. 1 times 5x is 5x. And then 1 times 6 is 6. Now, when you get to this point, okay, and this cancels right here, you really don't have to keep multiplying because, or subtracting, excuse me. Because whenever I do negative 7 minus 5x, I get negative 12x. But there's nothing I can multiply x squared by to give me negative 12x. So this right here would be our slant equation. Not the eraser, sorry. So my slant asymptote equation would be y equals x plus 1, okay? So now that we have found what our slant asymptote is, now let's go back and talk about our range. So anytime that you have a slant asymptote, your range is going to be negative infinity to positive infinity, or all real numbers, okay? So again, I'm going to reinforce that. Anytime that you have a slant asymptote, your range is all real numbers, okay? So now I'm going to go in here and I'm just going to graph what I already have, okay? Just graph your intercepts and then your asymptotes, okay? So my x-intercepts were negative 5, 0, and 2, 0, okay? I have a hole at negative 3, 10, all right? I have a y-intercept of 0, negative 5, okay? And then I need to go ahead and put my vertical and my horizontal asymptotes. So my my slant asymptotes. So my vertical asymptote was at x equals negative 2. Okay. And then my slant asymptote, use purple, was at x plus 1. So we're going to go up here to x plus 1. And I put a point so it helps me. Okay. Just kind of try to stay straight. Sorry, I know that's kind of hard. Okay, and so then from here, once you get to this point, just go ahead and just connect your graph as best as you can. Oops. Remember, that's a hole. I shouldn't have drawn my line through the orange here. Okay, so there would be our graph, okay, of this equation. Okay, now if at any point right now you need to pause this video to go over this, kind of go back, you can always rewind it. That's why I want y'all watching it individually, because you can go at your own speed. Okay, but I'm going to go on and go to page 2, kind of example 2, if you will. Okay, so on this one, okay, they go ahead and they give you your f of x and your g of x. Again, in order to write the equation, we're going to see, well, where are my x-intercepts? So my x-intercepts for f of x are at negative 4 and negative 2. Okay, so that means that, that means that my factors up here for f of x are going to be x plus 4 and then x plus 2. Okay, well, then I need to go to g of x and see, well, what are my factors of g of x? So notice the only x-intercept I have on this one is negative 4. So that means that, my g of x is just going to be x plus 4. Okay. Now, before we can go any further, we need to make sure that we don't need to have that a value in front. So what I mean by that is, I'm going to write the number so you can visually see what I'm talking about, and then I'm actually going to erase it. But I'm going to see, do I need to have a number in front of this up here? Okay. And I'm going to show you how to check that. Whoops. Okay. All right. So what we're going to do, we're going to multiply the top out first. Get my different color going. So x times x gives you x squared plus 4x plus 2x plus 8. So all I just did is I foiled. Let me write that 8 a little bit better. Okay. And then obviously on the bottom, I still have x plus 4. And yes, I know that x plus 4 can cancel, but give us a second and we'll talk about that in a minute, okay? All right. So what I need to do though, I need to combine my terms on the top, I'm sorry. So I have 4x and 2x, so I'm going to combine those. And that's going to become x squared plus 6x plus 8. Good grief. 8. And it's going to be over x plus 4. Okay, so what we're going to do is we're going to check to see if we need to have an A. So it tells, or what we talked about on Friday is we're going to check, and I'm going to go ahead and make this note, check y-intercept. Okay, so as a reminder, over here on our y-intercept, we should have 16. Okay? Ignore that. That's the y-intercept of this. I don't know what I was... Okay, never mind. Ignore that. I'm sorry. Okay, so we're going to check what our y-intercept should be. That's what I should have said. I'm sorry. So what we're going to have here is we're going to go... Pin. Okay, so we're going to say, okay, I'm going to plug in a 0 everywhere there's an x. Because remember, your y-intercept, x is 0. So I'm going to say, okay, 0 squared plus 6 times 0 plus 8 over 0 plus 4. Okay? So I know 0 squared cancels to 0, and 6 times 0 also cancels to 0. So I have 8 over 0 plus 4, which is 4. So that means that when we check our y-intercept, we have a 2. So whenever we have our factored form, and since I wrote all that in blue or black, I'm going to write it here, I should have a 2 here. Okay, so what I did to find that 2 is I plugged in 0 for x, and whenever I solved it, whatever number I came up with, that was the number that goes in front of your factored form. Okay, all right, so I'm going to go ahead and fill out the table. I've showed y'all how to fill the table out by now. Surely y'all can figure that part out. If you can't, of course, ask, but I'm going to go ahead for time's sake and just fill this out for you. Remember, you can do it either on your calculator or you can do your g of x divided by, your f of x divided by your g of x. 2, 4, 6, 8, 10, 12, 14. Okay, so here's our table. Okay, so let's go ahead and figure all this out. All right. So, sorry, ignore me for a second. There we go. Okay, so our domain, so we have this undefined function here, or undefined value. So whenever we're writing our domain, we're going to have negative infinity to negative 4 with a union, negative 4 to positive infinity. Okay. Now we need to see, well, actually, back up. I'm a step ahead. Sorry. So then we're going to skip our range for a second. And so we're going to go and find our x-intercepts. And remember, x-intercept is anywhere where your y value is 0. So that means that our x-intercept here would be negative 2, 0. Okay. Now, from our table, we know that, from our table, and then when we look at our factored form, we know that our whole has to be right here at negative 4 because those are the shared factors, right? So whenever we have our whole, we know that it's negative 4 is our x value, and then I need to find what my y value would be. So I'm going to use just the factors that are not in common. So we're going to use that coefficient of 2, and we're going to use the x plus 2, and that's it. Because notice we don't have anything else on the bottom that isn't shared. Okay, so we're going to go down here for a whole. So our y value of whole, and we're going to say, okay, well, remember, I'm just going to rewrite it so you can see it here. Remember, it was, 2 times x plus 2, okay? That was the equation we're going to use to plug it into. So we would say, well, 2 times negative 4 plus 2, okay? Well, negative 4 plus 2 is negative 2, so 2 times negative 2 gives you negative 4, okay? So the y value of your whole would be negative 4, okay? All right. So then we move on to our y-intercept. Again, y-intercept is where x is 0. Just because I like to make sure that y'all are following where I'm at. Just in case you need some help, I'm going to go ahead and change the colors and highlight this. Okay, but our y-intercept is going to be 0, 4. Okay, and then we look for our vertical asymptote. Well, remember, to find the vertical asymptote, we would see, well, what isn't shared in the bottom? Okay, well, there's nothing. So because there's nothing shared, that is going to be a none. Okay, there's not going to be a vertical asymptote. Okay, now when we get to our horizontal or our slant asymptote, okay, this one's going to be a little bit different because if, as we just talked with our vertical asymptote, we have the x plus 4 on the bottom. That's the only factor on the bottom. But they both, that's the shared factor. So there's not anything left on the bottom that isn't the shared factor. So it's not going to be a horizontal, and it is going to be a slant this time. Okay. Now I know what you're saying, what you're going to say about our ranges, but you said that the slant is always all real numbers. Okay. This is a special case. Okay. So in a special case like this one, where you don't have you don't have a denominator that isn't a shared factor. Let me say it that way. Okay. Because you have a denominator, it's just a shared factor with the numerator. So when you don't have a denominator that isn't a shared factor, we would say, okay, it's just going to be y times 2 plus x plus 2. But we need to simplify this. So that's going to be y equals 2x plus 4. Okay, and this here would be our equation for our slant asymptote. Okay. You can also then have found it by simply dividing. When we take our, let's go ahead and do that real quick, actually. Just because that's the way that we typically do it anyway. But what we're going to do is we're going to multiply out the top, okay? So remember, if you will, when we multiplied our two factors on the top, we got x squared plus 6x plus 8, okay? But now I have this 2 in front. So what I have now, I'm going to write it up here. 2 times x squared plus 6x plus 8. That's my top. But I'm going to go ahead and factor it, or not factor it, excuse me, distribute. So we have 2x squared plus 12x plus 16. And it's divided by the denominator, which is x plus 4. Okay? So another way to find our slant asymptote would just be to simply say, okay, 2x squared plus 12x plus 16 divided by x plus 4. Okay? So I need to multiply x by 2x to get x squared, or 2x squared, excuse me. 2x times 4 gives me 8x. All right, so my 2x squareds cancel, and then 12x minus 8x gives me 4x, and I bring my 16 down. All right, and so then I would need to multiply x by 4 to give me 4x plus 16. Okay, so here is our slant asymptote equation as well. Okay, so then the last thing we need to do on this one is just to solve, or to graph it, excuse me. So go ahead and graph what you know. So we know we have an x-intercept at -2. We know that we have a y-intercept of 0, positive 4. And then we also know we have a hole at -4, -4. Whoops. Okay. We don't have a vertical asymptote on this one, but we have this slant asymptote. So we're going to go ahead and just connect it. Whoa, that was not straight whatsoever. Sorry. Okay. Surely y'all can draw a better straight line than I am on my iPad. However, what do you notice, though, about this one that has been different about all the other graphs? It doesn't make that little funky, I don't know what you want to call it, shape, right? Where it kind of looks like a mountain in a valley or something. I don't even know. I don't know how to describe it. It doesn't make a typical rational function, right? So the reason for that is because when you had that shared factor up here, so I'm going to move my screen up to show you. We have our shared factors here, and I'm left with essentially nothing else. Let me say it that way, on the bottom. So because we don't have anything else on the bottom, we just have that top function, excuse me, and so we just have a linear function on this one, okay? And again, the reason is because we have that x plus 4 that was on the denominator is your shared function, okay? Okay, again, pause the screen if you need to. If you need any kind of clarification on that, you can pause it and go back if you need to. All right, moving on to page 3. So on page 3, they don't give you the table this time. They only give you the graph, okay? And you have to discover from here, well, what do you have, okay? All right, so, sorry, I wanted my copy, so I'm thumbing through what I have here. Okay, so we know based off of our graph here, All right. So just honestly, just kind of pick where you want to start. But because I'm going to do the domain, I noticed that, okay, look here at this x equals -1. That's going to have to be my vertical asymptote. Okay. So vertical asymptote we know is going to have to be x equals -1. And we know that because if you look at the green graph right here, it's getting really close to -1. Same thing up here. It's kind of hard to see that it's approaching -1 because of where the graph is, but it's going to get really close to -1, but it's not going to touch it there. All right. Well, then I notice also that right here, it's going to get really, really, really close to y equals 3, but it's not going to touch it. So that's going to be our horizontal asymptote. Okay, we're going to have a horizontal. So we know it's going to be y, excuse me, not x. That's going to be, well, y equals 3. Okay. And going back to my domain, because I started it and didn't finish it, sorry. Okay. I also see, well, there's a hole here at 2. That's important to know because remember, if there's a hole, that means it doesn't include that value. So I know I'm going to have to go from -infinity to -1. Okay. And then I'm going to have a union, and from -1, I'm going to go to 2 because at x equals 2, there's a hole. Oh, I mean to erase that, sorry. Then I'm going to have another union, and I'm going to say, well, 2 to positive infinity. Okay. So that whole thing there, all 3 of those kind of pieces is our domain. Okay. All right. Well, then I need to now do the same thing, but with my range. I'm going to use a different color so you can tell I'm doing something different here. So we'll just use red. All right. So for my range, I'm going to come from -infinity. So going down to the bottom, I'm going to come to -infinity all the way up here to 3. So range is -infinity to 3. I wish I could move this thing. Maybe one of y'all will tell me how I can do that later. All right, and then I go from 3 to my hole, because remember, it doesn't include the hole. So I'm going to go from 3 to 5, and then that's a U, by the way. And then I'm going to pick back up and go 5 to infinity. Okay. All right. Okay, so there's our range. So now we're just going on our table here. Now we're looking at our hole. Well, here's our hole. I've already drawn my arrow right here, okay? And the point is at 2, 5. So my hole is going to be at 2, 5. Okay. X-intercepts is going to be -3, 0. My y-intercept is 0, 9. Okay. Okay, so now let's talk, now that I've got all that part filled out, let's talk about how we can write our rational function here. As a reminder, I'm going to go ahead and make a note right here, as I did on my little, when I worked it out here. Because there's a horizontal asymptote, that means it must have same degree in numerator and denominator, okay? And the reason that it has to have the same degree is because we have a horizontal asymptote, okay? All right, so now let's go ahead and write this bad boy, okay? And I'm hoping that I'm going to be able to explain this where you're like, oh, okay, that makes sense, okay? So just starting off, I'm going to have a number in front of my factors. And that number is going to be this thing right here. Okay, so your horizontal asymptote is going to be your first value here. So make yourself a note if you want to. Horizontal asymptote. Okay. All right, now moving on. The next thing on the top, I have to account for my hole. So if my hole is a +2, that means in factored form it would be x minus 2, right? Well, if it's a hole, it has to be in the top and it has to be in the bottom. Okay, so this -2, this part comes from our hole right here. Okay, now I need to take into consideration my x-intercept. Okay, so my x-intercept, I'm going to use that in my numerator. Okay, so this thing here I'm going to use when I do this. Well, here, let me just do it this way. So if it's an x-intercept of -3, I would write it in factored form as x plus 3. Okay. So that is your intercept. There we go. Okay. And then the bottom thing that needs to go on the bottom of our, or the last thing that needs to go on the bottom of our function here, our vertical asymptote. We need to take into account a consideration of that. And so my vertical asymptote, if it's x minus 1, the way I would write that as a factor is x plus 1. Okay, and so that is my vertical asymptote. Okay, so I know some of you have sent me help on, I'm not remember, I can't remember, sorry, if it was part 2 or part 1, or part 3, excuse me, part 2 or part 3 of your homework. But hopefully what I just went over, and I'm going to go over it the exact same way in our next example, but hopefully this helps you on that specific problem. Okay, so horizontal asymptote is going to go in the front. Consider your whole, and so whatever your whole is, make sure you have that factor in the top and the bottom. Your x-intercept, that factor will go on the top, and then our vertical asymptote, that factor will go on the bottom. Okay? All right, so let's go down here to our next example. Okay? And let's go ahead and just label what we know here. Okay? So we know that we have, I'm going to use this I think it's pretty blue. We know we have a vertical asymptote here at -2, and I have another one here at +1. It's vertical asymptote, okay? I can also see right here that there is a horizontal asymptote here at +1. Now, because of this funky thing that's going on in the middle, our range is still going to include 1, but whenever you look at the rational part on the ends, it's still going to approach +1 but never touch it, okay? So our range is still going to include 1, but the vertical asymptote, horizontal asymptote will be headed towards 1, okay? Will be that x equals 1. All right, I can see that there's a x-intercept at 4, 0. I also have an x and a y-intercept at 0, 0. Let me do my y-intercept a different color. Y-intercept is at 0, 0. Okay. I'm trying to think if there was anything else that I can see, but I don't think there was. Okay, so let's go on to our domain. So our domain, let's use purple. There we go. Okay, our domain. So on our x-axis, we go from -infinity to -2 with the union. And then we go from -2 to -2 to +1. Unions are not looking like use. Union, and then I go from +1 to +infinity. Okay. And then, as I said, because of this really funky function, I'm going to do it in yellow. This one right here, because of that function that's in yellow, that makes it where our range is -infinity to +infinity, okay? It's all real numbers here, okay? Now, did we have a hole in our graph? Was there ever a time that we had a point that it was not included? Nope. So our hole, we're actually not going to have one. Okay. And then as we've already talked, our x-intercepts are going to be 4, 0 and 0, 0. And then our y-intercept was also 0, 0. Whoa. Okay. So just trucking along, our vertical asymptotes were going to be x equals -2 and x equals 1. We have 2 of them on this one. Okay. And then as we talked, this one does have a horizontal asymptote, and that horizontal asymptote was at y equals 1. Okay. Okay, so think back to what we talked about a while ago when we were writing our equation. Okay. Horizontal asymptote goes in the front right here. Okay. Now I'm going to write a 1, but just know you're not going to put a 1. Like, I want you to visually be able to see, though, that my horizontal asymptote goes right there. Okay. Then we have, in our top, we have our x-intercepts. So remember, we have 2 x-intercepts. Okay. So for just a second, I'm going to show you as a reminder. Okay. So one of our x-intercepts is 0. So I would write that as x plus 0. That's how I normally write my x-intercepts, is x plus the number, right? But does plus a number change anything? No. Or plus a 0, excuse me. Plus a 0 doesn't change anything. So I'm just going to leave this part as x. Okay? X is the plus 0. So then my next x-intercept was positive 4. So because it's a positive 4, I'm going to put x minus 4. Okay? Now I'm going to make this note, and I suggest that you do it if you kind of forgot, or maybe you think you will forget. Write yourself a note that x would be x plus 0, okay? Well, here, I'll write the word plus. But plus 0 doesn't do anything. Okay, so that's why we're just going to leave it as an x, just as an x, okay? All right, so then I move on to my bottom. Am I going to have a shared factor on this one? Think in your head for a second. So if you're not sure if you're going to have a factor on, or a shared factor on this one, did we have a whole? We didn't have a whole, so because we didn't have a whole, we're not going to have a shared factor, okay? So now for the bottom, my denominator, I'm going to get the information from my vertical asymptotes. So one of my vertical asymptotes was negative 2. So the way I would write that in factored form is x plus 2. Okay. And then the other one was positive 1. And so the way I would write that in factored form is x minus 1. Okay. So just as a refresh, like a recap, if you will. Okay. Let me zoom out so we can see it. Okay. There we go. Okay, so I've highlighted in yellow the 1 because the number in front is going to come from our horizontal asymptote. Now, I highlighted it to show you that that's where it would go, but remember, you're not going to write a 1 at the front because 1 times anything is just itself, okay? The x here that's by itself, that would actually be x plus 0 from our x-intercepts. But x plus 0 is really just x because adding 0 doesn't change anything. Okay, the next thing is x minus 4. And the reason it's minus 4 is because our other x-intercept is positive 4. And in order to write it as, in order to write the x-intercept of positive 4 as a factor, it would be x minus 4. And then moving on to our denominator, we get our denominator factors from our vertical asymptote. So our vertical asymptote was x equals negative 2. And so the way to write that into factored form would be x plus 2. And then our other vertical asymptote is a positive 1. And the way to write that in factored form would be minus 1. Okay. All right. Now on to the last 2 examples. And we're almost finished, I promise. Okay, just the 2. Okay, so now they don't give you the graph. They actually just give you the information that you need, okay? And so as a reminder, okay, we're going to kind of go through this one somewhat quick, okay? And I'm going to use the different colors. Horizontal asymptote goes in the front. Pin, okay. Horizontal asymptote was 2, so there's going to be a 2 in the front, okay? Now notice this one has a hole. And we know it because it literally says hole. So we have a hole at 4. So because it's a positive 4, we know we have to have x minus 4 in the top and the bottom. Okay? So this comes from our hole. Okay? Then the next thing we know, on our top, we need to have our x-intercept. Well, our x-intercept is a negative 3, so we know it's going to have to be, sorry, x plus 3, because, again, the x-intercept is negative 3. So the way that we would write that is x plus 3. And then the last thing on the bottom is that we have to include the vertical asymptote on the bottom. Okay, so on the vertical asymptote here of negative 2, we need to include that in the bottom. And so the way to include that in the bottom, if it's x equals negative 2, we would write it as x plus 2. Okay. Now, one thing that we need to double check is our y-intercept, okay, to make sure, does this all add up? Does it all make sense? So what we're going to do is, well, hold on, I need it right there. Okay, we're going to say, okay, my y value of my y-intercept is 3. So I'm going to say, well, 3 equals, and now I'm going to use my factored form over here, but anywhere I see an x, I'm going to put a 0. So I would say 2 times 0 minus 4 times 0 plus 3, okay, over 0 minus 4, 0 plus 2, okay? So then I'm probably going to do more steps than some of you need. That's okay. I'm just going to simplify it. So 0 minus 4 is negative 4, 0 plus 3 is 3, over 0 minus 4, which is negative 4, 0 plus 2 is 2. All right, so that gives me 3 equals 2 times negative 4 is negative 8, times 3 is negative 24. Negative 4 times 2 is negative 8. So then I find, well, sorry, 3 equals 3. So yes, this is right. This is correct, okay? And so we have it in factored form, and now I just need to make it into standard form, okay? So we're going to go ahead and do our box method or FOIL, however you're comfortable with, or whatever you're comfortable with. And I'm going to do x minus 4x plus 3. So we get x squared minus 4x plus 3x minus 12. So combining like terms on the top, I have my 2 from the front, okay? That 2 came from right there. So then I have x squared minus x minus 12 over, and I'm going to do x minus 4x plus 2, x squared minus 4x plus 2x minus 8. So that's going to be x squared minus 2x minus 8. Okay, and the last thing I just need to do is just distribute the 2 inside to bring it down here to my standard form. So that would become 2x squared minus 2x minus 24 over x squared minus 2x minus 8. Okay? All right, I want you to pause the video, okay, at this time, and I want you to try this last one. I'm going to work it, okay? But go ahead and pause the video and work it, and then come back and see if you did it right, okay? All right, so just again, going through all this. So we know that we have, or we don't have a horizontal asymptote on this one. So we actually don't have to worry about a number in front of our factors. So moving on, I see that we have a hole at negative 3. So I'm going to go ahead and include that in both the top and the bottom. So because it's x equals negative 3, the way I would write that is x plus 3, both on the top and the bottom, because they're both holes. Okay, so this part came from the hole. Okay, moving right along onto the top, I would have my x-intercepts. Okay, so I have an x-intercept at positive 2 and 1 at negative 4. So if the x-intercept is at x equals 2, the way I would write that is x minus 2 in factored form. And then if I have an x-intercept at x equals negative 4, to write it in factored form, I would write x plus 4. Okay. All right, so those came from my x-intercepts. And then the last thing I need to make sure that I include as far as on my equation here is my vertical asymptote. And since it's at positive 4, my factor would be x minus 4. Okay, one thing to make sure that you remember, okay, or one thing to point out, is make sure that this is a positive 4, so it has to be x minus 4, because it can't be x plus 4, because if that was the case, that would also be a whole because it's a shared factor. All right? Okay, so now what we're going to do is we're going to check our y-intercept. So check y-intercept, and we're going to do it the same way we did up top in the same section. Okay, so I'm going to plug in, because my y-intercept here is 2, 0, or 0, 2, excuse me. I'm going to plug a 2 in. I need you to go. Go find Daddy.
Mommy, no,
Okay, 2 is going to go into y. And then I'm going to plug a 0 in everywhere I see an x. Okay.
Mommy,
So I'm going to... I need you to go. I'm busy.
go.
So I'm going to plug in a 0. Sorry, 0 plus 3. 0 minus 2. 0 plus 4 all over 0 plus 3. And then 0 minus 4. Okay. All right. Again, I'm going to be doing some steps that some of you probably don't need, but I'm going to do it anyway. So 3, negative 2, and 4 over 3 and negative 4. Okay. So that would make 2 equals 3 times negative 2 is negative 6 times 4 is negative 24. 3 times negative 4 is negative 12. So that becomes 2 equals 2. Okay. All right. So our y-intercept's good so far. So then I also need to go ahead and put this into standard form. And then the very last thing we're going to do is we're actually going to divide our numerator divided by our denominator to check our slant asymptote to make sure everything's right. Okay. So let's go ahead and multiply out our numerator. So, oops. So I'm going to do x plus 3 and x minus 2. So we get x squared plus 3x minus 2x minus 6. Okay, so that gives me x squared plus x minus 6. Okay, and I still need to multiply that by x plus 4. Okay, so we get x cubed plus x squared minus 6x plus 4x squared plus 4x minus 24. Let me check myself. Yep. Okay. All right, so my numerator is going to be x cubed plus 5x squared minus 2x minus 24. And I need to multiply out my denominator. Okay. So we're going to multiply x plus 3 times x minus 4. So we get x squared plus 3x minus 4x minus 12. Okay. And so that's going to become x squared minus x minus 12. Okay. So again, as I said, our last step to do is, I'm going to make a note right here. We're going to divide. We're going to divide to check the slant. Okay, so we're going to divide to check the slant. Okay, so all we're going to do is we're going to do x cubed. Hold on, I need to move this. I think I'm moving it too far down. So, whoa. X cubed plus 5x squared minus 2x minus 24. And we're going to divide by x squared minus x minus 12. Kinley, I'm almost done. I will help you in a minute. Go on. Thank you. Sorry about that, guys. All right, so x squared times x will give me the x cubed. So I'm going to multiply by x. X times x squared is x cubed. X times negative x gives me negative x squared. And x times negative 12 gives me negative 12x. Okay. All right, so my x cubes will cancel. 5x minus negative x squared. 5x squared minus negative x squared. I'm going to leave change. And I'm going to make that 6x squared. Negative 2x plus minus negative 12x changes to a plus plus. So negative 2x plus 12x gives me plus 10x. And I'm going to bring down my negative 24. All right, so the last thing I can multiply x squared times 6 to give me 6x squared. Six times negative x gives me negative 6x, and 6 times negative 12 gives me negative 24. Okay? My negative 6x is canceled, so x plus 6 should be my slant, and we see that it is right there, so we know we did it right. Okay? All right, so if you have any questions over 8.3, feel free to email me. I am going to be gone, or on Monday during class, I'm going to be headed to the junior high track meet. And so just know that I may be a little busy. I will try to answer any emails that I may get as quickly as I can. But feel free by any means. If you need to come in Tuesday during jacket period, that is always an option as well. So just a recap of some of the announcements I said at the beginning. You will have your test on Tuesday and Wednesday, unless you've already set up another time for you to take it because you will be out. So Tuesday, Wednesday, you will have a test. I would like for you to have 8.3 homework done. You need to have all your eight part 1, 2, and 3 homeworks done before your test. That's just to help you on your test itself. Technically, though, just know this: if you don't make the best of grades, but you still have an attempt, you will still have until Friday at midnight or at 11:59 p.m. to get those done. Okay, March 7th is whenever the Unit 8 closes. Okay. So on Thursday and Friday, if you've already taken your test, then they'll just be work days in class to do that stuff. I'm trying to think if there's any other announcements, but I can't think of any. I have already posted the rubric in Remind, so make sure you check that there. And if you have any questions, just let me know. Have a great day.